So we'll just revise it. The concept of multiplexing is what? It will refer to the combination of information streams from multiple sources for transmission over a shared medium. So multiplexer is the device which will help you to implement this uh, multiple streams to be transmitted at the together. And demultiplexing is what? It will be the separation of the combination back to the separate information streams. So this is the demultiplexer. This is a shared medium. So over the same shared medium, you have number of senders which will be sending the data. This will be multiplexed, which will be transmitted on the shared medium, and at the time at the receiver end, they will be demultiplexed. So there are different type of multiplexings. You have frequency division multiplexing, which is FDM, WDM, which is wavelength division multiplexing, TDM, which is time division multiplexing, and CDM, which is code division multiplexing. TDM, FDM are widely used. WDM, wavelength division multiplexing, is basically a form of frequency division multiplexing, which is used in optical fiber. And you have your CDMA, which is used more generally in your mobile communication. This is FDMA, frequency division multiplexing, which is actually you are having this this is frequencies, that is the number of users which are separated with this frequency. Here the same frequency is given for different users on at different time slots. And the CDMA is like there will be some code which will be provided and for the user. So we'll see what is a FDM. It is like multiple signals can be modulated using different frequencies. So you have different frequencies which are used, which will be modulated, and they can be multiplexed together, and then they are transmitted. So there will be some center frequency or bandwidth, and which is larger than the total bandwidth of the all multiplex signals. And at the receiver end, again, they will be uh, demultiplexed. There is a modulator and demodulator. This is going to help to increase the overall data rate, increase the immunity to interference, and this scheme works well where noise is likely to interfere with some frequencies at a given time. So example, like you have transmitted TV signal, total bandwidth is 6 megahertz. So audio carrier operating at one particular frequency, color subscribe carrier, video subcarrier, they will be using different frequencies. Okay, so you can have many channels which can be multiplexed together in this one particular uh, transmit FDM example. You can have different voices which can be combined together. That is frequency. That is you are having FM. We won't go like how this all these frequencies, they will be separated with some guard band also. We won't go into the many more details of this, but you just remember frequency division multiplexing is different frequencies will be multiplexed together, and then they will be transmitted. In wavelength division multiplexing, FDM with multiple beams of light, basically it is used in optical fibers. So when you are using a light transmission, so multiple beams of light at different frequency will be transmitted using FDM. So that becomes a WD, WDM. And here there is another type like dense wavelength division multiplexing, DWDM. You have TDM, which is time division multiplexing. So it is like the multiplexer accepts input from attached devices in a round robin fashion. That means it will take every user will be given some time slot, and the entire frequency will be allocated. So that is one same frequency will be allocated to multiple users with the time slot. So example is T1 and ISDN telephone lines are common examples of synchronous time division multiplexing. So you have uh, This is the multiplexer. The frequencies will be allocated to different users using the time slot. So you are this is the time slot, or you call it as a frame, so that one frame will contain number of users data which will be transmitted. You will see in detailing clear you have the concept of framing. There are different carriers you must have seen, you must have heard about, like T1, T2, T3, T1 carrier, T2 carrier, with different kind of data rates. This is a CDM, that is code division multiplexing. In code division multiplexing, you have like you have actually this is having the CDMA is a there are two types. You have frequency hopping, which can be used, or you have direct sequence spread spectrum technique, something like that. So here each user regularly hops frequency over a available spectrum. So the transmission, the carrier frequency which is used for modulation is selected differently at different time slots. So say for example at first time slot you have this frequency, then in the second time slot you have this frequency. So the carrier frequency is changed. There is a frequency hopping. Okay, and there is some unique hopping pattern or the code which is assigned to this. So how it is identified? Basically, it is identified with the code. That is why the name as code division multiplexing. Okay, basically, this is used with the cellular system. When you will study mobile, you will see there is a CDMA, the CDMA technology. Do you have a separate technology only which is using this like in mobile communication? So this is something like this same frequency is only there is no uh, like there is a single frequency can be used by multiple users, and every user will have some code. So that code will be used to identify the user's data. So the advantages and disadvantages of various techniques. FDM, it is very simple. We have like used in radio, TV, cable TV. All the receivers, such as cellular telephones, do not need to be at the same location for FDM. But the disadvantage is noise problem, because generally it is used with analog signals. So this is going to waste the bandwidth, and it is limited by frequency ranges. In synchronous time division multiplexing, you have digital signals relatively simple, commonly used with T1 and ISDN, and it also wastes bandwidth. Statistical time division multiplexing, more efficient use of bandwidth. Frames can contain control and error information, and packets can be of varying size. This is more complex. Disadvantages: it is more complex than this STDM and WDM. Very high capacities over fiber signals, can have varying speeds. It is scalable. The disadvantages: it is costly. There is complexity. CDMA is you have large capacities, scalable. Disadvantage again, it is complex. Primarily a wireless technology. This is about FDM, TDM, and CDM. So this is covering. Module 2. Is there any doubt till now, whatever we have studied?
No, ma'am.
ये क्या किसने किसने लिखा है पीडीएफ विजिबल है कि नहीं है पीडीएफ विजिबल था ना
पहले था
पहले नहीं था ओके बट हुआ ना बाद में विजिबल हुआ ना
यस मैम विजिबल था एफटीएम का
ओके so I think this completes your module 2 physical layer topic. Next time we will start with data link layer. Any doubt in this two modules you can ask me, and I am not uploaded the material. I will be uploading it today.